Welcome everyone. Today in GATE series of numericals, we'll be seeing a question of engineering math. This is a question of most probable value. This question has came in GATE 2023 and the question number was 29. So the question is the figure shows three distance observations D1, D2 and D3. The table lists value of this observation and the corresponding weight. Assuming uncorrelated observation, the most probable value by least square approach for the measurements are dash. Okay, so d1, d2, d3 are given and also this weight are given. So let's see, L1 we are taking as 40.15, L2 is 40.18, okay, and L3 also is 80.39. Okay, so by least square, the residual should be minimum. Okay, so what is residual formula? So phi will be equal to w1 into x1 minus l1 square plus w2 x2 minus l2 square plus w3 l3 x3 minus l3 square. Okay, so this will be minimum. Okay, so actually differentiation we have to do uh, and make equation. So first we have to define, so we'll take differentiation with respect to everything x1, x2, x3, and there will be one lambda term. So Lagrangian we are defining here. So lambda means one fixed equation which we have, like x1 plus x2 is equal to x3. So this equation first with respect to lambda is one like error term you can assume, or correction term, so that will be introduced in everything. Okay, so w1 x1 minus l1 square, like this term only here. Okay, so first we'll take with respect to x1, nothing, just this is one addition term which is a fixed equation. So equation we write down x1 plus x2 equal to x3. So this is x1 minus x1 plus x2 minus x3. So this fixed term we have to introduce here in addition to this residual. Okay. So d phi by dx, so that we get that equation. So d phi by dx1, what it will be, and lambda will be introduced in each term. Okay. So d phi by dx1 will be, this differentiation we will take 2w1 x1 minus l1 plus lambda. So d phi by dx2, similarly do 2w2 x2 minus l2 plus lambda. Okay. Now d phi by dx3, so here also 2w3 x3 minus l3, and here minus lambda will come. Okay, and then another we will take with respect to lambda. Okay, so that will be, which is our fixed equation, that is x1 plus x2 equal to x3. So here, okay, so this is what we have done, we have formed the equation. So now from this, every term should be equal to 0. So like x1 we are, we have to find, so x1 minus l1 40.15 into 2, and w1 is given here 1. So okay, plus lambda. Okay, so here when we will solve this, we'll be getting 40.15 minus lambda and this by 2. Okay, similarly for x2 also we'll do this. So directly I'm writing because everything is same. So 40.18 and here lambda by 4 will come. This is not whole minus, okay, because it was multiplied by 2. So this is 1 minute. I will cut this. 40.15 minus lambda by 2. X2 is by 4 because of weight 2 here it will become 4, and x3 will 80.39 plus lambda by 2. Okay, so from this we also know this fourth equation we'll be using. So x1, that is 40.15 minus lambda by 2 plus x2 40.18 minus lambda by 4 plus equal to x3. Okay, so equal to 8.39 plus lambda by 2. So this equation when we'll solve, we'll get lambda value is equal to I will do in calculator, that is minus 0.048. Okay, so now we have to, in this equation we have to minus this and we will get x1 value. Okay, so x1 will be how much? X1 will be 40.15 minus minus plus it will become 0.048 by 2. So what will be 40.15 plus 0.024? So this will be the answer. Okay, similarly we can find x2 x3. Okay, so that will be the answer. X2 x3 value you will be getting by putting lambda. So that's all for today. Thank you. Tomorrow again we'll see next type of problem.